Okay, remember how to solve by graphing? So this is where you're going to have a system of equations. I'm going to graph these two lines and then see where they intersect. So remember that to graph this, I need to first graph 0, negative 4. That's the y-intercept. Slope of 3. So I graph that point. Slope is 3. Draw my line. Then I've got the second line. The second line is in point slope form. So I've got the point 2, negative 4, and the slope of negative 3. So my slope, my point is 2, negative 4. Slope is negative 3. Draw that line. And they intersect in that point, even though I didn't do a very good job of graphing it with my ruler or anything. And remember, the solutions are where the two lines intersect. And it's a point. It's an ordered pair. So in this case, the solution is 1, negative 1. Remember, there are some disadvantages to graphing and finding the solution based on the graph. One being that it's got to be very, very neat in order to see the correct point where they intersect. So on my graph, they didn't quite intersect at that point because I didn't do a very good job of graphing it. Remember, another disadvantage was that sometimes you're going to have to estimate. And if you estimate, you may or may not get the right answer. So now let's talk about a way to solve a system that's going to give me the correct answer every time. And that's called substitution. Solve a system of equations by substituting. So hopefully you're thinking, oh, you're going to have to put something in place of something else. That's substitution. In this case, I know that y is the same as 3x minus 4. So down here I have another y. Those have to be the same. So I'm going to take this 3x minus 4 and put it in place of this y, because they're the same. Y equals 3x minus 4. They're the exact same value. So this is 3x minus 4 plus 4. That's y equals negative 3x minus 2. Then I'm just going to solve just like normal. I'm going to distribute on this side. I'm going to combine like terms. I'm going to move the x's to the same side. So I have 6x equals 6, which means x equals 1. But remember that a solution is a point. It's an ordered pair. So I need to figure out what's the y value. I know x. What's the y value? Well, I know from up here that y equals 3 times x minus 4. So that means 3 times 1 minus 4. Y equals negative 1. Could I have chosen the second equation, y plus 4 equals negative 3x minus 2, and solved for y? Totally. Will you get the same answer? I hope so. Same answer. So my solution is the x value, which is 1, comma, the y value, negative 1. Hopefully you can see that that's exactly the same as what we got by graphing. See how those are the same exact points? Or same exact lines, I mean? And they intersect in the same point. Okay, let's try this next one. Y equals 6x minus 11 and negative 2x minus 3y equals negative 7. So this I'm going to do the same thing. I'm going to substitute. I know that y equals 6x minus 11. So I'm going to put that in place of the y on the second equation. Now I'm just going to solve. Got to distribute that negative 3. Combine like terms. Move that 33 to the other side, and then divide by negative 20. So x equals 2. Then I need to know, what does y equal? So you get to pick whichever equation you want to use. If you want to use this first one, or if you want to use the second one. You get to choose. I'm going to choose the first one, because I don't know about you, but I think that one looks easier. So then my solution is the ordered pair, 2, 1. That's my solution. What about this next problem? Well, I know y equals negative 5x minus 17. So I'm going to put that in place of the y up here. Negative 3x minus 3 times negative 5x minus 17 equals 3. So negative 3x plus 15x plus 61. Oh wait, 51? 51. So then negative 3x plus 15x is 12x. 12x equals negative 48. X equals negative 4. I'm not finished yet because I need to figure out what y equals. This time I'm going to choose the first equation just to mix it up a little bit. So if I have negative 3x minus 3y equals 3, I can put negative 4 in for x, and I can solve. So that would be 12 minus 3y equals 3. Negative 3y equals negative 9. Y equals 3. So my solution is negative 4, 3. And that's it. Seem pretty easy? I hope so. This one is all you. So pause the video and you try it. Figure out what x and y is. Great. Now that you've done that, you need to turn that in tomorrow. Alright, so let's look at number 5 now. This time, I don't have x equals or y equals something. But I can change it, right? I can change this equation so that it's y equals 6 plus 4x. Now I've got y by itself. I know this is y, so I can put that in place of the y. So that'll be negative 5x minus this whole thing. Distribute. Combine like terms. And solve. So I know x equals negative 3. Now I'm just going to put that in place of one of my equations. Your choice. I'm going to go with the first one. Which means my solution is negative 3, negative 6. How can I check to make sure I got the right equation, or I got the right solution? Well, I can substitute it in. So it does negative 4 times negative 3 plus negative 6 equals 6. Is that true? Well, that's 12 plus a negative 6. Does that equal 6? Yep. Is it enough to check just one equation? No, not at all. So now I need to check the second equation. Is negative 5 times negative 3 minus negative 6 equal 21? So that's 15 plus 6. Does that equal 21? Yep. Since it worked in both equations, that means I got the right solution. Okay, what about this problem? I don't have the x by itself, and I don't have the y by itself. In this problem, if I choose the first equation, and try to solve for y, I will get negative 2y equals 7x minus 13. Divide by negative 2. So I'll get y equals negative 7 halves x plus 13 over 2. Now before you go reaching for your calculator to change that into decimals, let me tell you something. That's going to be rough to work with, right? Those numbers, you don't like fractions. So if you can avoid it, avoid it. In this problem, you can avoid it. Let's look at this equation. Can I solve that for x? If I get x by itself, I'll get x equals 11 plus 2y. Is that okay? Yeah. Now I've got 11 minus 2y, that's the x value. So I'm going to take that x value and put it in here for x. So now I've got negative 7 times x, which I know is 11 plus 2y, minus 2y equals negative 13. So now let's solve this. Negative 77 minus 14y minus 2y equals negative 13. Combine like terms. Add 77 to both sides. Divide by negative 16. So this time y equals negative 4. So how do I figure out what x equals? I just plug that in. So x equals 11 plus 2 times negative 4. I used this equation this time. But it doesn't matter. You can use the first one. You can use this one. You can use this second one. Or you can use this third one. It's your choice. So then x equals 3. And when I write my solution will be 3, negative 4. So that's my x value and that's my y value. Well, that's great. But what if I have one of those systems that's inconsistent and can't be solved? There's no solutions. So let's look at what one of those looks like. I'm first going to solve this for y. I think that will be the easiest. Then I put 3 plus x in here for y. So negative 3x plus 3 times 3 plus x equals 4. Negative 3x plus 9 plus 3x equals 4. Combine like terms and I get 9 equals 4. Since that's not true, that means there's no solution. So that means the system is an inconsistent system. If it happened to be a dependent system, your dependent system would have a true statement. So a dependent system would get something like this, 9 equals 9, something that's true. And that means it's dependent, and instead of there being no solutions, that means there's an infinite number of solutions, right? It's the same line. Okay, let's try a couple more problems. So here's number 8, and I want you to do this one. So pause the video, try it, see what you get, and come back. Alright, now that you've done number 8, try number 9. Tomorrow in class, these are the first 3 things that we're going to be going over. So pause the video, try solving these 3. Alright, so now that you've done that, now that you've solved these 3, hopefully tomorrow we can start right away and jump into any questions you have about substitution. Good luck tonight!